Okay, so picking back up here, example D with adding. What has to be true in order to add and subtract fractions? Yeah, we need a common denominator. So, first thing I want you guys doing, do my denominators factorial. And the reason I would skip this one, so we did a lot of adding on Friday, but there's a couple in homework like this with a denominator or parts of the problem that are x squared minus y squared. How does x squared minus y squared factor? I think I heard it. My hint is 2 parentheses there. You know x squared, right? X squared is going to break into x and x. What's y squared break into? Y and y. And if it multiplies to be a negative y squared, we need a plus and minus. That's difference of squares.
You did 2 addition.
Okay, not even sure why. Okay, it's supposed to be an x plus y and an x minus y. I don't know. I've been off today, and that just goes to continue with the day. But x squared minus y squared, realize it's no different than factoring x squared minus 4. It's difference of squares. I just knew that it would probably throw some of you for a loop if I didn't mention it. Okay? So, the other one is x plus y. Doesn't really factor. Let's talk about least common denominator. I always start by asking what's in common. What do we have in common between our two denominators? X plus y, x plus y. So that is part of my least common denominator. After you get anything that's in common, look for any leftovers. Do I have any leftovers? There's an x minus y I haven't used. And so x minus y is the other part of my common denominator. So we're going to add these two fractions together by getting a common denominator. So I'm going to rewrite my fractions with my common denominator. X plus y, x minus y, x plus y, x minus y. Okay, so both fractions are going to have the same common denominator. What do you notice about the first fraction? If we look up here, my common denominator, or my denominator, was already x plus y, x minus y, wasn't it? So I already have the common denominator. What's that mean about my numerator? It doesn't need to change, does it? Just carry it down because we already have the common denominator. So x plus 3y is carrying down. Second fraction. I'm supposed to have a denominator of x plus y, x minus y. But to start with, I only had x plus y. What am I missing? I'm missing the x minus y. So that means I need to multiply by x minus y to get my common denominator. Well, if you multiply the denominator by x minus y, we're multiplying the numerator by x minus y. And so that means I'm going to be multiplying 8 by x minus y. Okay? Now, if you went ahead and multiplied that together, more power to you. I'll do that here in this next step. Okay. I have two fractions with the same denominator, so when I add them, I can add the numerators and just keep the denominator. So I'm going to go ahead and write my denominator as x plus y, x minus y. My numerators, x plus 3y plus, what do I need to do with the 8 and the x minus y? Yeah, we need to multiply those, so we're going to distribute. And that's going to be 8x minus 8y. Okay. Clean it up. We're almost there. Denominator is x plus y, x minus y. What about the numerator? 8x and x plus 8x is 9x. 3y minus 8y is minus 5y. Always check at the end. Is there any factoring I could do that could lead to simplifying? Does 9x minus 5y factor? No. If there's a GCF, I'd want to go for that. But it doesn't. So does anything cancel? No, I'd have to have an x plus y or an x minus y to cancel out the denominator. So I am done right there. Okay. Sound a little bit familiar from Friday? Okay. Top of the back side, there's 3 subtraction problems. I have a feeling we'll only do 2 of them because A, I didn't really leave quite enough room to get all 3 in there, and B, I want to make sure we need to hit some of those bottom ones, don't we? So those are probably more intimidating at this point. So, let's go ahead and look at A. Subtracting is really not a whole lot different from adding, is it? So we need to get those denominators and factor them. Does 3y plus 15 factor? Yeah, how's it factor? Okay, GCF, right? So if I divide them both by 3, I'm going to put the 3 out front. When I divide them both by 3, I have a factor of y plus 5. What about 5y plus 25? Does it factor? GCF of 5. When I factor out a 5, I'm left with y plus 5. Okay. Thoughts on our least common denominator? I keep asking the same questions every time. What's in common? Okay. We already know. There's y plus 5. That's got to be part of our common denominator. What are my other pieces? There's a 3. There's a 5. So that means 3 and 5 are going to be part of my common denominator. Now, depending on your situation, you can write it as 3 times 5 times y plus 5, and I probably will at first. However, it can also be written as 15 times y plus 5. In other words, you can go ahead and put that 3 and 5 together. And that's what I'll definitely put in my final answer. Okay. So, common denominator. I think for this purpose right here, I'm going to say 3 times 5 times y plus 5 plus common denominator, 3 times 5 times y plus 5. Okay. Common denominator is supposed to be 3 times 5 times y plus 5. What's my first fraction missing? It has 3. It has y plus 5. We're missing the 5. So what do I have to do up here? I have to multiply by 5, right? So we need to multiply here by 5, which means I have to multiply here by 5. So I need to be multiplying 5 times y minus 1. Okay, I have to pause. Did I say it wrong, or did I just write it wrong? What type of problem are we doing here? Subtraction. What's that supposed to be? Subtraction. I don't know if I said it wrong or if I just wrote it wrong, but don't do what I did. Don't follow my example today. I'm obviously setting bad examples. Okay, resume. Second denominator. It's supposed to be 3, 5, y plus 5. What are we missing? Originally we were missing a 3. So we're going to multiply by 3. So I'm going to be multiplying 3 times y plus 3. Okay, ready to put it together? And again, the trick on this one is the subtraction. Make sure we don't mess up our signs. Common denominator. I'm going to go ahead and put, say, 3 times 5 is 15 times y plus 5. If you want to leave it as 3 times 5 for another step or two, you can. Just if they don't cancel, put them together by the end. What do I need to do with 5 times y minus 1? Multiply them, right? Distribute. So that's going to be 5y minus 5, yes? What do I need to do in the second fraction? Distribute the 3. Now, there's a couple different ways we can think about this. But when we distribute that 3, how do I want to do this? I think I'm going to say, okay, this is a subtraction problem, right? So I'm going to say we are subtracting everything in this second from the second fraction. And so 3 times y is 3y, plus 3 times 3 is 9. So the idea is we're going to be subtracting the 3y plus 9. Now, a different way to think about that, you could have also thought of that 3 right here as a negative 3 and just distributed a negative 3. If you like that better, that's fine as well. I've been struggling with what's the best way to teach this today. So, one way or another, on top I have 5y minus 5. And then at some point, if I now distribute this minus, it's a minus 3y and a minus 9. So whether you do that now or whether you did that in the previous step, you just have to remember it's subtraction, so all the signs on that second fraction change. Still over 15 times y plus 5. Okay, did you clean it up already? What cleans up? 5y minus 3y is 2y. Minus 5 minus 9 is minus 14 over 15 times y plus 5. Same final question as always. Is anything factor? Is anything going to cancel? Yeah, can we at least factor the top? Again, I'm not sure what Savas is going to expect. If we factor a 2 out of the top, it's 2 times y minus 7 over 15 times y plus 5. Does anything cancel? No, nothing cancels. Okay? I'm perfectly fine if you leave the first answer, as long as you kind of at least do a mental check, does anything cancel? I'm not sure what Savas will say, but I'm fine if you leave the first answer. Okay. Not a whole lot different, is it? Now, I think we'll just do B or C. C is probably the better example to do. It's a little bit bigger and beefier, isn't it? So let's look at C. If we have time, we can come back and do B, but we're going to be pushing to get through all these examples today. So, looking at C, what's the first thing we need to do? Yeah, factor, right? Does x squared minus 16, x squared minus 6x minus 16 factor? Okay. 2 parentheses, x and x. What'd you say? X plus 2, x minus 8. Okay. Multiplying to be negative 16. adding to be negative 6. So plus 2 minus 8. What about x squared plus 6x plus 8? Does it factor? Part of me wants to say, haven't all the denominators factored today? Or in Friday? X squared, x and x, multiplying to be 8, adding to be 6. Plus 2 plus 4? Okay, I'm going to write it up here. And who knows, maybe you're pros, you're not even writing it down. But least common denominator. Start with asking yourself, what's in common? Both denominators have an x plus 2, so that's part of my least common denominator. Anything else in common? No. So what are my leftovers? There's an x minus 8 that's going to go to my common denominator, and there's an x plus 4 that's going to go to my common denominator. Okay. You know what to do? Remember, this is a subtraction problem. Common denominator is x plus 2, x minus 8, x plus 4. X plus 2, x minus 8, x plus 4. I went ahead and wrote it out in both my denominators. And obviously, as you start to do this on your own and you get the flow for it, you can adjust the steps to your liking, correct? I show a lot of steps. If I'm doing this on my own, I wouldn't show all these steps. But I know at the beginning we need them. So, okay, first fraction. I need the common denominator, x plus 2, x minus 8, x plus 4. What was it missing? It's missing the x plus 4. So we're going to come over here and we're going to multiply by x plus 4. Top and bottom, right? Since x plus 4 is what I'm missing. So that means in my numerator, I'm going to be multiplying x plus 4 times x plus 1. I personally will do that on the next step. If you are in multiply, awesome. Second fraction. Which denominator was it missing? It had x plus 2, x plus 4, so it's missing x minus 8. So I'm going to multiply top and bottom by x minus 8. That means I'm going to be doing x plus 1 times x minus 8. Okay, let's see. My denominator, I have the common denominator of x plus 2, x minus 8, x plus 4. So I have them written out, right? How do I multiply my numerator of the first fraction? FOIL, distribute, whatever floats your boat there, right? So, x times x, x squared. X times 1, 1x. Distribute 4. 4 times x plus 4x. 4 times 1 plus 4. If you went ahead and cleaned that up and said 5x in the middle, that's great. Now, what are we doing here with these two fractions? We are subtracting. So I'm subtracting everything from this next fraction. You can change the signs as you go if you want. For me, for today, I'm going to write them down and then I'll change them in my next step. So x times x, x squared, minus 8x, Then I distribute my 1 plus 1x minus 8. So you'll notice there I have everything from the second fraction in parentheses because I'm subtracting that whole quantity. Okay, writing it out again. Common denominator. X plus 2, x minus 8, x plus 4. If you want to subtract right here, go for it. I'm going to write out my whole line of numbers so I can put them together in my next step. In that I still have the x squared plus, I skipped over a number, plus 1x plus 4x plus 4. What's this minus say we're going to do? We're minusing all the terms, right? So it's minus x squared minus negative 8x is plus 8x minus 1x minus negative 8 is plus 8. Okay? I'm doing lots of steps. There's lots of ways you can do this on your own. Okay? X plus 2, x minus 8, x plus 4, denominator. I keep rewriting it, don't I? Okay. What cleans up here? X squared minus x squared? 0. What about x's? 1x and 4x is 5x plus 8x. 13 minus 1. 12x. Constants. 4 plus 8 is 12. Is there factoring? Technically, there's a GCF, isn't there? And some of you are looking ahead and saying, but it's not going to factor. It's not going to cancel. I get it. So if you factor out GCF of 12, it's 12 times x plus 1, still all over the x plus 2, x minus 8, x plus 4. You're going to see me factor it every time because I want you guys stopping and thinking, okay, does it factor? Does something cancel? I realize more often than not, nothing cancels, and that's fine. But I want you thinking it through for the times that something does cancel. Okay? I don't know if anyone got industrious and tried B, but if you do, the answer is negative 4 over x plus 1 times x minus 1. In case anyone cares and wants to try that. I am going to move on to complex fractions. Are you ready for the fun stuff? In all honesty, most of these problems have less steps than the other ones we've been doing. So. Okay. As you start looking at A, or any of them, we have fractions within fractions on all of these, don't we? So your first step is going to be looking at the denominators and looking for a least common denominator, because we're going to get rid of all of this nastiness. And the best way to do that is to multiply by the least common denominator. So as I look at A here, 2 minus 1 over x, x plus 2 over x. What do you see in denominators? We have a denominator of x. We have a denominator of x. Anything else? No. So if my denominators are x and x, what's my least common denominator? It's already there, isn't it? I already have a common denominator of x. So my least common denominator is x. And what we're going to do is we're going to multiply the top of this fraction by x, and we're going to multiply the bottom of this fraction by x. Now, as we go to do that, one thing that means is my x has to distribute, right? Because on top there's not one, but there's two terms. And same thing on bottom. There's not one, but there's two terms. So that x is going to multiply into every term on top and every term on bottom. And by multiplying by x over x, we're not changing the value of this because we're just multiplying by x over x, which is 1. Now, I think for visual help today, I'm going to do my normal and write it out the long way. In that, I'm going to write out this problem. The original problem was 2, I'm going to leave a space, minus 1 over x. X, leave a space, plus 2 over x. Because what will be helpful for some of you is to see us physically multiplying each piece by x. So I'm going to multiply the 2 by x. I'm going to multiply the 1 over x by x. On the bottom, I'm going to multiply x by x. And I'm going to multiply 2 over x by x. Okay? Now, I can ask now or later. That x, when I multiply that x by fractions, what is x as a fraction?
No.
X over 1, right? You can make anything a fraction by putting it over 1. So on these, I'm going to think of them as x over 1. Okay, guys. Clean it up and we're done. On top, what is 2 times x? 2x. That was tough. Okay, minus 1 over x times x over 1. Okay, x over x. What is x over x? 1, right? Something divided by itself is 1. What I actually think about is I actually think about cross-canceling here. I have an x on top and an x on bottom, and they can cancel. And when they cancel, they become 1s. 1 times 1 over 1 times 1 is just a big old 1. If you'd gotten x over x, that would reduce to be 1. Okay, denominator. X times x. X. Did anyone say it? Squared. X times x, x squared. Plus, what about 2 over x times x over 1? You could say 2x over x, but the x's will cancel. 2 times 1 over 1 times 1, which is just 2. Same final question we've always done. Does anything factor or cancel? 2x minus 1, no GCF. X squared plus 2, not if it's x squared plus a number. That's not going to factor. Anything cancel? No. 2x minus 1 are married terms. X squared plus 2 are married terms. Guess what? You're done. Okay, so if you can identify that least common denominator, multiply by it, it will make the problem much more doable, right? I know that looked horrible, but in all reality, we didn't do anything that horrible, did we? I don't know. Some of you may still think so, but... Okay. Same thought process on B. Start with... I need a least common denominator. So look at your denominators within the fractions. What kind of denominators do I have? X and Y, right? So when we think about least common denominator, grab, okay, what's in common? 2 of them have an X in common. 2 of them have a Y in common. Anything else ever in the denominators? No. So what's my least common denominator? XY. What am I going to multiply every single term on top and bottom by? xy. Now, for the benefit of being able to see it, I'm going to write it out. And I'm going to show that we're multiplying every term by xy. I'm going to take 3 over y. I'm going to leave a space so I can write an xy by it. I'm going to take 7 over x. I'm going to multiply that by xy. I'm going to multiply 1 over y by xy. And minus 2 over x is going to get multiplied by xy. What is xy as a fraction? Xy over 1. So I'm multiplying by xy over 1. Okay. 3 over y times xy over 1. What cancels? Y cancels with y, leaving me with 3 times x, 3x, plus 7 over x times xy. What cancels? X cancels with x, leaving me with 7 times y, 7y. Denominator, what cancels? Y cancels with y, leaving me with x. Minus 2 over x times xy, what cancels? X, leaving me with 2y. Anything cancel or factor? No GCFs, no factors to cancel. You got it. Okay. Do I have time for both of these? To be safe, I want to make sure we get D in. Because D looks a little bit different, doesn't it? I want to make sure we get D in. C is just like what we've been doing. We'll try and get it in if we have time. It's going to be borderline, okay? Now, D, I'm going to teach a little bit differently. Because first of all, I don't want to look at my denominators and make a common denominator out of that stuff. Because I'm going to want a factored form. But also, my recommendation, I want you to see this as one big fraction divided by one big other fraction. And I'm actually, to make it a little less messy, is I'm going to write it out sideways. In that, I'm going to write out the first fraction, x squared minus x minus 12 over x squared minus 2x minus 15. And then that big line means that this is a division problem. And then, so we're dividing by the bottom fraction, which is x squared plus 8x plus 12 over x squared minus 5x minus 14. What do you see? I changed this in the setup, so this is a fraction divided by a fraction. We keep change flip, right? This is no different than what we did in lesson 4.3. I would do a keep, change, flip. Or what your math teacher should be saying as multiply by the reciprocal. Keep, change, flip really has no mathematical meaning, but it's how we all remember it, isn't it? So, multiply by the reciprocal. I'm going to keep x squared minus x minus 12 over x squared minus 2x minus 15. What am I going to change? Division to multiplication. And what am I going to flip? Second fraction. It's now going to be x squared minus 5x minus 14 over x squared plus 8x plus 12. What do we do? Factor. Lots and lots of factoring. So we don't have to multiply that mess, right? That's nastiness to multiply. So, okay, here we go. X squared minus x minus 12. 2 parentheses, x and x. Give me some numbers. Okay. Minus 4 plus 3. Multiplies to be negative 12, adds to be negative 1. Denominator, x squared minus 2x minus 15. X and x. Minus 5 plus 3 would multiply to be negative 15 and add to be, negative 2. X squared minus 5x minus 14. X and x. Minus 7 plus 2. Multiplies to be negative 14, adds to be negative 5. And x squared plus 8x plus 12. X and x. Plus 6 plus 2 will multiply to be 12 and add to be 8. Well, was all that factoring worth it? Yeah, what cancels? X plus 3's. X plus 2's. Anything else cancel? No, because we have 4, 5, 6, and 7. So nothing else cancels. Final answer. Do you remember how to express this? This goes back to last lesson. To multiply them together, just multiply them into the same fraction. We're not actually going to multiply them. We're going to leave them factored. But x minus 4 times x minus 7 over x minus 5 times x plus 6. The last couple of problems in homework are just like this one, which is why I wanted to give you something to look at, that looks like it, to see it. It's very doable. It takes us back to last lesson. It's just kind of crazy looking, and that freaks everybody out. Okay, we can look at C real quick. There's not really time to start on homework, so. Just writing the homework down real quick. On C real quick, at least talk about what would be your common denominator that you would multiply by. This is taking us back to the other method, isn't it? What do you see in the denominators? An A, a B, an AB. So what's that make my least common denominator? AB, right? Everything either has an A, B, or both in it. So we're going to multiply everybody by AB. So 1 over A is going to be multiplied by AB. 1 over B is going to be multiplied by AB. And A squared minus B squared over AB is going to be multiplied by AB. What's AB as a fraction? AB over 1. So every single term is getting multiplied by AB over 1. What cancels? A cancels with A, leaving us with a B. What cancels next? 1 over B times A over B. B's cancel, leave me with A. Denominator. AB cancels with AB, leaving me with A squared minus B squared. Am I done?
Oh no, you can factor out
Okay.
plus b minus
You need to factor that denominator. A squared minus b squared factors into a and a, b and b, plus and minus. My numerator is b plus a. What do you need to recognize here? A plus b is b plus a, isn't it? So guess what? They cancel. What remains on top? 1. So final answer for this problem would be 1 over a minus b. As I said, wanted to try and get that one in with you if I could, because you're going to see examples like these in the homework. I tried to pick things similar to homework problems to give you guys a good idea of what to do. Okay. Homework's going to take, there's not a ton of problems, but some of this stuff takes time, doesn't it? So allow yourself time to do the homework. 4.4, do tomorrow. We should be ready to do 4.5 then, and we'll solve some equations tomorrow.